Varanasi has been the most sacred pilgrim place in India for several centuries, with 3,000 years of history and continuous habitation. Varanasi is also blessed with plenty of ground and surface water resources, being on the alluvial plain right on the bank of holy river Ganga. However, rapid urbanization in recent years has put a strain on potable water supply, with complaints from citizens ranging from inadequate supplies to contaminated water. The city of Varanasi is geographically divided by the river Varuna, a tributary of Ganga. Accordingly, the city water supply is hydraulically divided into Trans-Varuna and Cis-Varuna regions. Though Trans-Varuna region is currently being supplied by groundwater from power borewells, a new surface water source has already been planned and is nearing completion. Cis-Varuna region is predominantly served by the surface water source from the river Ganga, supplemented by a small percentage of groundwater from power borewells. The focus of the present study is on water supply for Cis-Varuna region. The total current population for the Cis-Varuna region is 13 lakhs. With 150 LPCD demand and appropriate allowances for losses, the total demand for water is around 225 MLD for Cis-Varuna region. The total installed capacity at the existing water treatment plant is 311 MLD, comprising 3 different plants of 61 MLD, 100 MLD, and 150 MLD. However, the 61 MLD WTP is completely dysfunctional and the other 2 rarely work at full capacity. Inadequate treated water coupled with loss of water in distribution results in intermittent water supply and associated problems, including poor water quality. Although the Cis-Varuna region water supply system is riddled with many problems common to most water supply systems in India, many components of the water supply system are in good condition and the rest can be rehabilitated to full design capacity at minimal cost. Restoring water treatment plant and the associated raw water supply system to full design capacity can help boost the consumer supplies to desired levels, simultaneously minimizing serious bad water quality problems. Concurrent rehabilitation of clear water pumps and electrical panels, centralized monitoring and control of all pump houses, restoration of bulk treated water feeder mains, installation of hydraulic system that automatically regulates flow rates to various ground level and elevated surface reservoirs will ensure equitable distribution of potable water to various zones.
The main reasons for the loss of carrying capacity are frequent leakages or burst conditions along the pipeline, breakdown of pumping machinery, and air entrainment from the periodic filling and draining of pipeline. Frequent leakage and burst conditions in turn are due to lack of proper surge protection system, inefficient check valves also known as non-return valves, and absence of non-slam air valves. Inadequate surge protection system. Every time the pump strip, water column slams on the check valves, both at pump station and along the pipeline. When slam pressures exceed pipe pressure rating, a leakage may develop or result in burst condition. In addition, repeated occurrence of slam pressures can progressively weaken the pipeline and subsequent burst condition. Damaged check valves. Conventional check valves get damaged over a period of time due to repeated occurrence of surge pressures. Once check valves stop functioning, there will be heavy backflow through the pumps, resulting in vibration of pumps and loosening of seals and eventual leakage of water within the pump station. The damage can be huge if the operators do not react within 1 or 2 minutes and close the valves. Periodic filling and draining of pipelines. Failed check valves and periodic pump trip events result in frequent draining of the pipeline. Ordinary air valves cannot release the air efficiently and air gets entrapped in the pipeline during subsequent pump startup operation, leading to severe loss of capacity. Ordinary air valves will also result in air slam conditions, and resulting high surge pressures can generate leakages or burst events along the pipeline. Frequent pipe burst conditions. Every time a pipeline bursts or a major leakage is developed, it takes anywhere from 6 hours to 1 day to fix the problem and restart the pumps, causing a disruption in treatment of water and supply of water too. Pipe repair works call for emptying of almost entire pipeline, and the draining process takes a long time and is often accompanied by loss of precious water and damages to the nearby crops. Exposed air valves. The conventional air valves are exposed to people who tamper them and steal water. The air valves may also become non-functional, which will have negative impact on the hydraulics of the entire scheme. These problems are not unique to Varanasi water supply scheme and are faced by almost all water supply systems in India. In addition to rapid deterioration of water supply infrastructure, loss of capacity increases the pump energy costs. For example, a 20% loss of pump and motor efficiency increases the energy costs by more than 2 crores each year for Varanasi Municipal Corporation. The water treatment plant at Aditya is in very good condition and can treat water at full design capacity once the raw water side of the system is rehabilitated. Treated water is then distributed to various ground-level and elevated service reservoirs within the corporation limits and from there to individual consumers. There are problems associated with distribution of treated water as well. In the stage of bulk distribution of treated water, achieving equitable distribution of bulk treated water to ground and elevated service reservoirs is almost impossible, and traditional method of manual throttling is a very tedious process. No matter how well a system is designed, the inevitable variation in residual heads will distort flow of water into each reservoir, which results in inequity. In the stage of supplying water to households, once again, inequity will set in, as flow water to various households is dictated by gravity and hydraulics. The supply process is done manually, which is also a reason for unequal distribution. Manual operation. The entire scheme is operated and managed manually by untrained manpower and hence mismanaged, leading to many failures of pumps and pipeline. Every failure leads to considerable downtime for repairs and maintenance, resulting in disruption of daily water supply and recurring unexpected and unwanted expenses. Though the pumping machinery, surge protection system and some segments of pipelines are in badly deteriorated condition, the overall water supply infrastructure is still very valuable and should not be abandoned. Instead, a good rehabilitation program can unlock the value of existing infrastructure and strengthen the water supply scheme to original design capacity at a fraction of the cost of building a new water supply scheme. Varanasi Municipal Corporation and the Public Health Department have taken up the task of complete rehabilitation of the existing water supply scheme with an aim to restore full carrying capacity of the raw water system and enable assured and equitable distribution of treated water. The rehabilitation work was also based on the most advanced and time-tested technology from around the world in order to prevent rapid deterioration of various components in the future and minimize operational energy costs. Solutions to the main problems pertaining with the existing system are: bladder vessels-based surge protection. These maintenance-free devices provide excellent compressed air-based surge protection for pipeline systems. They protect pipelines from both extreme low pressure and extreme high pressure conditions, thereby preventing future leakages and burst condition as well as enhancing the life of pipelines. Pump control valves in place of check valves. State-of-the-art Israeli pump control valves will replace the check valves to help with smooth starting of pumps and automatic stopping of flow reversal when there is power failure. The sturdy construction for pump control valves make them fail-safe even under extreme operating conditions and prevent the need for the operators to run and close the isolation valves. Since there is no slant condition, All equipment within the pump station are very well protected and pumps will continue to operate at high efficiencies for a long time. Enhancing carrying capacity of the pipeline. Preventing entrapment of air along the pipeline is the key to maintain high carrying capacity of pipeline. The rehabilitation work employs the world's best Israeli air valves from Mari that will provide a fail-safe mechanism of removing residual air. In addition, the rehabilitation work involves continuous monitoring of the health of air valves, so preventive maintenance work can be undertaken in case of necessity and keep the pipeline in healthy condition all the time. Prevention of pipe burst conditions. Pressures will be monitored at each pump station using high-speed data loggers, and that data will be analyzed periodically to determine the potential surge problems. This will address the problems right away before they get worse, thereby preventing future pipe burst conditions. Overcoming the inequity in distribution of treated water. Installing Reservoir Management System (RMS) at the inlet side of each receiving reservoir, which automatically shuts off the flow into reservoirs once a designated quantity of water is delivered to that reservoir. And for supplying to households. Usage of zonal control valves based on energy-less hydraulic solution called WDMs, which are set to deliver certain flow rate, volume and for designated time period. This will facilitate 24/7 supply over a period of time. Reduction in operating energy costs. Replacement of pumps to bring back full efficiency and replacement of electrical panels for synchronization of pump station operation, which results in reduction of operating costs of energy and maintenance. Overall project management through continuous monitoring and control. For efficient operation and maintenance, all critical components of the system such as bladder vessels, air management system, reservoir management system, are connected to a smart network. The officials will be able to see the system working on their computers and smartphones and will be receiving alerts, intimations, on-demand access to historical data. This allows for informed decisions in cases of vandalism, pipe leakage and unintended deficiencies in the system in real time. With these best water management practices, state-of-the-art technology solutions and smart network tools by Sankat, the Varanasi water supply system can be restored to original design capacity at a fraction of new water supply system cost. These changes will also ensure long-term trouble-free operation. The post-rehabilitation scenario will be a reliable water supply scheme that is fully automated with improved efficiency and assured water supply to the people of the Varanasi on a daily basis.